Okay, hi everyone. It's been a while since I've done any videos. So today we're going to continue with Windows Server 2003. So share my screen. Okay, Chapter 5. Managing the Dynamic Host Configuration Protocol, DHCP. So Microsoft exam objectives covered in this chapter: manage DHCP clients and leases, manage DHCP databases, manage DHCP scope options, manage reservations and reserved clients, troubleshoot DHCP, diagnose and resolve issues related to DHCP authorization, verify DHCP reservation configuration, examine the system event log and DHCP server audit log files to find related events, diagnose and resolve issues related to configuration of DHCP server and scope options, verify database integrity. So, overview of DHCP. DHCP's job is to centralize the process of IP address and option assignment. Simply put, you can configure a DHCP server with a range of addresses and other configuration information and let it assign IP parameters like addresses, default gateways, DNS server addresses, and so on. DHCP is defined by a series of requests for commons RFCs, notably 1533, 1534, 1541, and 1542. In brief, here is the DHCP process. 1. When TCP IP starts up on a DHCP-enabled client, a special message is sent out requesting an IP address and a subnet mask from a DHCP server. 2. Any DHCP server that hears the request checks its internal database and replies with a message containing the information the client requested. The contents of this message vary depending on how the DHCP server is configured. There are numerous pieces of information that you can specify to pass to the client on a Windows Server 2003 DHCP server. When the client accepts the IP offer, the address is then extended to the client for a specified period of time called a lease. If the DHCP server has given out all the IP addresses in its range, it won't make an offer. If no other servers make an offer, the client's TCP IP initialization will fail. In the following sections, we will examine the advantages and disadvantages of DHCP and take a closer look at the DHCP process, advantages and disadvantages of DHCP. DHCP was designed from the start to simplify network management. It has some significant advantages, such as the following. DHCP capability is bundled with Windows Server 2003, so adding to your network doesn't cost anything extra. Once you enter the IP configuration information in one place, the server is automatically propagated to clients, eliminating the chance that a user will misconfigure some parameters and require you to fix them. Configuration problems are minimized, clearing up a labyrinth of possible situations that lead to big messes and obscure, hard-to-find problems. IP addresses are conserved because DHCP assigns them only when a client requests one. IP configuration becomes almost completely plug and play. In most cases, you can plug in a new system and move a new one and then watch as it receives a configuration from the server. Unfortunately, there are a few actual and potential drawbacks of DHCP. Not all DHCP client implementations work properly with Windows Server 2003's DHCP server. If you put incorrect information into your DHCP server, it'll automatically be delivered to all your DHCP clients, meaning you may have to visit each machine and reconfigure it. It can become a single point of failure for your network if you only have one DHCP server and it's not available. Clients won't be able to request or renew leases. If you want to use DHCP on a multi-segment network, you must either put a DHCP server or relay agent on each segment to ensure that your router can forward Bootstrap Protocol BOOTP broadcasts. The DHCP lease process. The DHCP lease process is pretty simple. There are 4 stages involved. 1, DHCP discovery. 2, DHCP lease offer. 3, DHCP lease request. 4, DHCP lease acknowledgement. At the end of the process, and if all goes well, the client will have an IP address and whatever other parameters the DHCP server owner wanted to supply. Because an IP address is required to communicate with other devices on a TCP IP network, the DHCP negotiation happens very early in the Windows boot cycle. So step 1, DHCP discovery. The first step in the DHCP lease process is the discovery stage. It's triggered the first time a client's DHCP configured TCP IP stack starts, or when you switch from using an assigned IP address to using DHCP. It can also occur when a specific IP address is requested but unavailable, or immediately after a formerly used IP address is released. At the time of the lease request, the client doesn't know what its IP address is, nor does it know the IP address of the server. To work around this, the client uses 0.0.0.0 as its address and 255.255.255.255 for the server's address. It then sends out a broadcast DHCP discover message on UDP port 68 and destination port 67. The discover message contains the hardware MAC address and the net BIOS name of the client. Once the first discover message is sent, the client waits 1 second for an offer. If no DHCP server responds within that time, the client repeats its request 4 more times, 2, 4, 8, and 16, plus a random amount of time from 0 to 1000 milliseconds intervals. If the client still doesn't get a response, it'll revert to automatic private IP addressing APIPA and continue to broadcast discover messages every 5 minutes until it gets an answer. With APIPA, the Windows client will automatically pick what it thinks is an unused address from the 169.254.x.y address block instead of waiting indefinitely for an answer. Even though an address has been signed, the DHCP client will continuously poll every 5 minutes for a DHCP server and then switch back to using a DHCP assigned address when the server becomes available. Step 2, DHCP lease offer. In the second phase of the DHCP lease process, any DHCP server that received the discover message broadcast that has valid address information to offer responds with an offer message. This feature allows you to configure multiple DHCP servers so that you're protected against a single point failure. You must register the Windows Server 2003 DHCP server in Active Directory, and it won't begin offering leases until it successfully registers in the directory. More on this later in the chapter in the section authorizing DHCP for Active Directory. The offer message is a proposal from the server to the client and it contains an IP address, a subnet mask, a lease period in days, and the IP address of the DHCP server offering the proposal. The IP address being offered is temporarily reserved so that the server doesn't offer the same address to multiple clients. All offers are sent directly to the requesting client's hardware MAC address. Step 3, DHCP lease selection. Once the client has received at least one offer, the third phase of the DHCP lease process begins. In this phase, the client machine will select an offer from those it received: Windows 2000, XP, and Server 2003. Typically accept the first offer that arrives. To signal acceptance, the client broadcasts an acceptance message containing the IP address of the server it selected. It has to be broadcast so that the server whose offers weren't selected can, on reserve, pull back the address they offered. Step 4, DHCP lease acknowledgement. Once the chosen DHCP server receives the acceptance message from the client, it marks the selected IP address as leased and sends an acknowledgement message called DHCP ACK back to the client. It's also possible that the server might send a negative acknowledgement or DHCP NACK to the client. DHCP NACKs are most often generated when the client is attempting to renew a lease for its old IP address after that address has been reassigned elsewhere. Negative acceptance messages can also mean that the requesting client has an inaccurate IP address resulting from physically changing locations to an alternate subnet. The DHCP ACK message includes any DHCP options specified by the server along with the IP address and the subnet mask. When the client receives this message, it integrates the parameters into the TCP IP stack, which can then proceed just as though the user had manually given it new configuration parameters. DHCP lease renewal. What happens when the lease expires or needs to be renewed? No matter how long the lease period is, the client will send a new lease request message to the DHCP server when the lease period is half over. If the server hears the request message and there's no reason to reject it, it sends a DHCP ACK to the client. This will reset the lease period just as signing a renewal rider on a car lease does. If the DHCP server isn't available, the client realizes that the lease can't be renewed. The client can then use the address for the rest of the lease period once 87.5% of the time. Percent of the lease period has elapsed. The client will send out another renewal request. At that point, any DHCP server that hears the renewal could respond to this DHCP request message, which is a request for a lease renewal with a DHCP ACK, and renew the lease. Anytime the client gets a DHCP ACK message, it must stop using its IP address immediately and start the leasing process over from the beginning by requesting a brand new lease. When a client initializes TCP IP, it will always attempt to renew its old address, just as with any other renewal. If the client has time left on the lease, it'll continue to use the lease until its end. If the client is unable to get a new lease by that time, all TCP IP functions will stop until a new valid address can be obtained. DHCP lease release. Although leases can be renewed repeatedly, at some point they're likely to run out. Furthermore, the lease process is an at-will process, the client or server can cancel the lease before it ends. In addition, if the client doesn't succeed in renewing the lease before it expires, the client loses its lease and reverts to APIPA. This release process is an important function that's useful for reclaiming extinct IP addresses formerly used by systems that have moved or switched to a non-DHCP address. So I'm going to leave it here for this live stream. Thank you for spending the time with me and have a good evening.